You know that moment you snap the perfect photo, find just the right filter, write a caption, and you tap share. It feels so simple, almost like magic. But behind that one little tap is an absolutely massive, planet scale engineering marvel. So today, let's pull back the curtain and see exactly what's happening. So, yeah, what really happens in those first few seconds? Well, your photo gets launched on this incredible journey. It has to be uploaded, processed, resized into a bunch of different versions, and then stored in a way that lets any of your followers anywhere on Earth pull it up in the blink of an eye. And the system has to do this perfectly, every single time.
And to really get why this is such a huge challenge, we have to talk about scale. We're talking about over 100 million photos and videos getting uploaded to Instagram every single day. Think about that. Each one of those has to be stored, basically forever, and be ready to go at a moment's notice.
Let's break that down even more, because it's kind of nuts. That's over 1,000 photos being uploaded every single second. Seriously, by the time I finish this sentence, thousands more photos have just started their journey. The system has to handle this constant, unbelievable flood of data without ever breaking a sweat. And here is the part of the story that just blows my mind. When Instagram was bought for $1 billion, this entire massive operation was being run by just 13 employees. 13! That's it. It just goes to show you that with really smart, really efficient system design, a tiny team can literally support a global phenomenon. All right, so let's follow the journey of one single photo. Part 1, getting from your phone to Instagram servers. The second your photo leaves your device, it gets funneled into this completely automated processing pipeline. It's got to get prepped and ready for its debut on the gram. This pipeline does 3 crucial things almost at the same time. First up, your photo gets compressed. This makes the file smaller, which is great because it means it loads way faster for everybody. Second, it's resized into multiple different versions. You know, a little thumbnail, a medium one for the feed, a full screen version. And finally, all its metadata, stuff like when and where the photo is taken, is pulled out and stored separately. Okay, so the photo is processed and ready to go. But where does the actual file, live? Part 2 of its journey is finding its forever home. And it can't just be on some regular computer hard drive. This system has to handle billions upon billions of files. Instagram uses a technology called object storage. Now, the easiest way to wrap your head around this is to think about your own laptop. Your computer uses folders inside of folders to keep things organized, right? Well, object storage doesn't do that. It just throws every single photo into one gigantic pool, and each photo gets its own unique ID. It's like a massive code check for data, and it's way, way more efficient when you're dealing with this kind of scale. So in the early days, even a standard object storage system wasn't quite fast enough. A traditional system has to do a little lookup to find a file, kind of like using the card catalog at a library to find a book. But when you have billions of photos, all those lookups create a massive traffic jam. So Instagram's engineers did something brilliant. They built their own system from scratch called Haystack. Instead of a slow catalog, Haystack keeps a super fast index of where everything is right in the computer's main memory. This completely slashed the time it takes to find and show you a photo. Now here's a key detail. No photo is ever stored in just one place. Every single image you upload is copied or replicated across multiple different servers and data centers all around the world. Why bother? Well, it's for 2 very simple reasons: reliability and speed. If one data center has a power outage or some other problem, your photos are totally safe somewhere else. And this also perfectly sets the stage for getting them to your friends super fast. So, storing a photo safely is one massive challenge, but delivering it across the entire planet in an instant, that's the final piece of the puzzle, and maybe the most impressive one. Part 3, the global delivery network. Let's just think about this for a second. Imagine you post a photo of a sunset in Los Angeles. How does your friend in Mumbai see it on their phone almost immediately? I mean, if that photo file had to travel all the way from a server in California across the ocean, you'd definitely notice a delay. So how do they solve this whole problem of physical distance? Well, the answer is a CDN, which stands for Content Delivery Network. Just think of it as a huge global network of servers with locations in pretty much every major city around the world. It's like a worldwide system of photo warehouses, all strategically placed to be as close to you and your followers as possible. And the magic that makes this all work is a concept called caching. When your photo starts to get some views, the CDN automatically makes copies of it and stores them on these local servers around the globe. So your friend in Mumbai, they're not actually fetching the photo from California. They're grabbing a copy from a server that's right there in Mumbai, or at least very close by. It's really the difference between ordering something from across the world versus just picking it up from the local store down the street. So we've covered the photo file itself pretty well, but what about all the data about the photo? The important stuff, the caption, the likes, the comments, the tags, that all has to live somewhere too. Section 4, managing the metadata. Instagram's strategy here is really smart and pretty simple. Use the right tool for the right job. For data that's pretty stable, like your user profile information, they use a classic, super reliable database. But for things that are changing constantly, like the like count on a viral photo, they use a totally different high-speed database that's specifically built to handle a nonstop flood of tiny updates for millions of people at once. So now let's zoom out one last time and just recap the big, brilliant engineering principles that make this whole thing work. These are really the core ideas that let Instagram operate at this absolutely insane scale. First off, to handle billions of users, you just can't have one giant database. It would grind to a halt. So Instagram uses a technique called sharding. Basically, they chop their main database up into thousands of smaller, more manageable pieces, or shards. This spreads the work out, so instead of one server getting crushed with requests, thousands of servers all share the load. It lets the system scale pretty much infinitely. We already saw this in action with the CDN. It's all about a smart caching strategy. Popular stuff, we call that hot content, like a celebrity's latest post, is kept ready to go on those fast edge servers close to users. Older, less popular photos or cold content can stay in the main storage. It's a simple idea that makes sure the most requested stuff is always the fastest to load. And finally, the big lesson from the Haystack story. By figuring out their own unique problem, that card catalog bottleneck, and building a totally custom solution, Instagram's engineers got a huge performance boost that they just couldn't have bought off the shelf. Sometimes, to solve a really big problem, you have to build your own tools. So let's bring it all home. That one simple tap on the share button kicks off a whole processing pipeline, stores your photo in a custom-built storage system, copies it all over the globe for safety, and then uses a massive CDN to deliver it in a flash to your friends. It's this incredible, beautiful symphony of technology all happening behind the scenes. And that kind of brings us to a final thought. Knowing everything we know now about building for massive scale, if you were one of those original 13 engineers facing millions of new users and with super limited resources, what's one thing you think you might have done differently from the very beginning? It's a pretty fascinating design problem to think about.